You think the Earth floats in space because some force is holding it up. Space has no up, down, left, or right, and there is no falling down. The phrase falling down is itself a lie that the Earth has used to deceive you for decades. In space, there is no floor and no ceiling. Even traveling 100 million light years, you won't hit a wall. So the question is, since there is no bottom, why no flyaway? Why does it orbit the sun? The answer is scary. Because the sun below Earth has dug an invisible pit. The Earth is not floating, it spins wildly inside this pit. Not escaping after 4.6 billion years. This pit is called the curvature of spacetime, which was discovered by Einstein. And its depth directly decides Earth's life and death. You might ask, how could a pit be dug out of spacetime? Isn't space empty? This is where Einstein was even crazier than Newton. More than 300 years ago, Newton discovered universal gravitation. It is said that an apple hit his head, making him think. Russell, why does the apple fall down instead of flying up? His answer was that the Earth has gravity, pulling the apple down. But Newton didn't tell us what gravity actually is. How can it cross the air, cross the vacuum, across millions of km? To pull things over? This puzzled scientists for 200 years. Then Einstein proposed relativity. He said that gravity does not exist at all. Right? The force that makes the apple fall, and the force keeping Earth in orbit, is actually no force at all. It is an illusion from warped space-time. How can we understand it? Imagine this. You place an iron ball onto a stretched bed sheet. What happens next? It sinks down, right? The depth depends on the iron ball's weight. Now, you place a glass marble onto the bed sheet. The marble won't sit still. It rolls toward the ball along the indentation. If the marble has sideways velocity, it won't roll straight into it. Instead, it will orbit around the iron ball. This is how Earth and Sun relate. The Sun's mass is 330,000 times that of the Earth. It warps space-time, creating a massive indentation. Earth is like that marble, sliding along this indentation. We call this kind of sliding orbiting. So Earth isn't pulled by the Sun, rather, it is in a curved space-time. It moves in a straight line. But in a curved space, a straight line becomes a circle. This sounds absurd, right? But in 1919, British astronomer Eddington proved this via solar eclipse observations. He discovered that light emitted from distant stars bends when passing near the sun. Light moves straight. If space-time were flat, light could not bend. But light did bend, proving space-time near the sun is curved. Einstein was right, space-time really can be curved, and what we call gravity is just this curvature. Here is the question, since the Earth is constantly sliding toward the sun, why doesn't it fall into the sun? The answer is that the Earth has a sideways velocity. Remember that marble on the bed sheet? Without sideways velocity, it rolls into the indentation. But if the marble has enough sideways velocity, it will orbit around the iron ball, and it will never fall in. Earth's speed around the sun is 29.8 kilometers per second. Meaning, a bullet goes 1 kilometer per second. So Earth is 30 times faster than a bullet, allowing it to circle the Earth in just 7 minutes. This exact speed lets Earth in the sun's depression keep gliding without falling in. What would happen if Earth suddenly stopped? Answer is here. After about 65 days, Earth would crash headfirst into the sun. Before everything on Earth evaporates from the sun's heat. But don't worry, this kind of thing won't happen in space. There is nothing that can make the Earth break. Space is a near-perfect vacuum. There is no air, no friction, and no resistance. The speed Earth acquired 4.6 billion years ago has barely been lost to this day. It will keep revolving until the sun dies. Speaking, you might ask, where did Earth's initial speed come from? This traces back to the birth of the solar system. 4.6 billion years ago, in the Milky Way, there was a massive cloud of gas and dust. We call it the primordial nebula. This nebula began to contract under its own gravity and began to spin. Why did it spin? Matter inherently has angular momentum. This is a law of physics, conservation of angular momentum. Simply put, once it starts spinning, it is hard to stop. Just like a figure skater, when they pull their arms in, spinning speed increases. The nebula was the same. When it contracted, its spin increased faster. Eventually, the sun formed at the center of the nebula, while debris forms the planets, with Earth. Earth inherited the rotation of that nebula, so it has been spinning since birth. This is Earth's speed source. Nobody pushed it, it has spun since it was born. Speed alone isn't enough. Earth ran steadily for 4.6 billion years also because it and the Sun reached a delicate balance. If speed were too fast, it would break from the Sun, flying into deep space, become a rogue planet, and eventually die in cold and darkness. If speed were too slow, the Sun's depression would swallow it, fall in, and burn into fire. With speed just right, can Earth neither fly away nor fall, orbiting the Sun safely and steadily? How did this just right speed come about? The answer is cruel. It was filtered out by the universe. When the solar system formed, there were countless pieces of debris. Fast ones flew away, slow ones fell into the Sun, only just right ones survived. Earth is a survivor of this cruel filtering process. Newton had a thought experiment more than 300 years ago describing this. He imagined putting a cannon on top of a very high mountain and firing cannonballs toward the horizon. If the cannonball is slow, it will fall back to the ground. If it is faster, the arc will be longer. If it reaches 7.9 kilometers per second, the arc matches Earth's curvature. That is to say, the cannonball will keep falling, but it will never hit the ground. Because Earth is round, while the cannonball falls, the ground also curves down. It never catches the ground and keeps circling Earth. This started the first cosmic velocity, the principle of Earth's orbit. At a speed of 30 kilometers per second, Earth is constantly falling from the Sun's gravity. But while falling, it moves sideways. So it never falls into the Sun. In a certain sense, Earth falls all along, but the direction always changes, ultimately forming an ellipse. This orbit is very stable. Scientists calculated the eccentricity, which is 0.017, almost a perfect circle. But this stability is not eternal. In fact, the Earth is moving away from the Sun by 1.5 centimeters a year. Reasons complex, mostly from Sun's mass loss and tides. At this rate, Earth is 1,500 kilometers further after 100 million years, having no impact on temperature. We must worry about the Sun's lifespan. In about 5 billion years, the Sun will enter the red giant phase. It will expand over 200 times, swallowing Mercury and Venus. Though Earth might not be swallowed, it will become a wasteland. By that time, even if the Earth is still orbiting the Sun, it won't suit life anymore. That is 5 billion years away. Now, consider another question. Why don't we feel any motion on Earth? Think about it. The Earth is flying at a speed of 30 kilometers per second, while rotating every day. The rotation speed at the equator is 465 meters per second. Why don't we feel a single thing? Because we move with Earth, and this motion is perfectly uniform. Remember riding in a train or plane? At a constant speed, you can walk around in the carriage. You don't feel moving at all. Only when it changes speed will you feel pushed or leaning. Earth same. Its rotation and revolution are both uniform, with no acceleration. So we cannot feel it. In addition, everything on Earth is moving together, including the air, water, mountains, rivers, and us. We lack a stationary frame, so we feel it less. All in all, the reason Earth can float in space without falling is not from a force, but for 3 reasons. First, there is no up or down in the universe, so the concept of falling itself does not exist. Second, the Sun's mass warps the surrounding spacetime, and Earth moves within this warped spacetime, making the path circular. Third, Earth has enough lateral velocity that while it is being pulled toward the Sun, it also moves sideways, ultimately forming a stable orbit. This ran for 4.6 billion years and continues until the Sun dies. We humans live right on this high-speed flying planet. Every second, travel at 30 kilometers per second through space. Every year, we return to the same position. This is not a miracle, it is just physics. But these cold laws of physics that give us a warm home. Let us look at the starry sky and ponder the universe. That is the magical part.